Hi, I'm George and welcome to part 37 of this never-ending Horizon series. Now this week we have a look at building the middle bracket here. Now this bracket has a few jobs that it needs to do. First of all, it has to hold the boosters together. It's also used to hold down the entire rocket while it's on the pad. It also supports the staging mechanism and also needs to support the weight of the sustainer under acceleration. So quite a few things. So let's go have a look how it's built. We start by making a set of trapezoid brackets that go from the central staging mechanism tube to the booster segments. These brackets are made from 3mm carbon fibre sheet because they need to be stiff and strong. And here they are after some sanding. So that we can attach them to the tube at the correct angles, we 3D printed these guides. The printed guides will serve a dual role as they will also be used as spacers when we put the final booster together. This is how they go together with the central tube that was made back in episode 3. Here you can see how that will go in between the booster segments. We're doing a test fit here on the master template. And here are the pads that will be added later. We hold everything together with a long bolt. We need to bevel one side of the brackets, as this side will be reinforced with more carbon fibre later over the top of it, and we don't want that big step in it. Okay, time to glue on the first set of brackets. We tack them on first with 24-hour epoxy. And then let that cure overnight. Once that's fully cured, we can go ahead and reinforce those joints. Each of these brackets is going to be carrying a load of around 1200 newtons, or about 120 kilos. It's kind of like doing tip to tip on fins. We then use a piece of baking paper as mold release and use a 3D printed wedge to compress the carbon fibre into the right shape. Pressure is applied in the form of rubber bands, which is enough to squeeze out some of the epoxy. The next day we can start tacking on the next pair of brackets. I don't know how many litres of 24-hour epoxy we've mixed over the years. Before we can glue the third set, we need to drill a hole for the stage's secondary lever. When the third set of brackets goes on, we won't be able to get to this hole. This hole needs to be drilled at a weird angle, which we'll discuss in a separate video. With all three sets of brackets tacked on, we can continue reinforcing all the joints between them. It's pretty much the same process as we've shown earlier, but this time we're using a slightly wider piece of carbon fibre, and we're also using a wider wedge to compress the cloth, as three of the gaps have a different geometry. Again, rubber bands are used to compress the wedge. A new technique we've learned is to wait about 6 hours where the epoxy is mostly set, but it's still soft. You can easily cut off the excess cloth with a sharp blade, which saves a lot of effort later in cutting and filing. Now it's time to add the pads that will ultimately attach the bracket to the booster segments. The surfaces are sanded and cleaned with methylated spirits again. We've sanded and cleaned the bracket as well, as later it will be a lot harder to get to. We put the bracket back in the master template so that we can align the pads properly and set them at the correct angle. Here we're inserting all the pads to give the correct spacing all the way around the bracket. We're using more of the 24-hour epoxy to tack on the pad. So the glue wouldn't drip, we did one pad at a time, so this took a couple of days to do all 6. After the glue has completely cured, we can remove the entire bracket from the template. Now we can start reinforcing each of the pad joints. We're using this piece of body tube to help hold everything in place. Here we're using 5 layers of carbon fiber cloth, again alternating weave direction with each layer. You can see the stiffness of the carbon fiber, how it doesn't want to conform to even a slight bend. The size of each layer also increases by several millimeters so that we get a nicely feathered edge. The last piece of carbon finally sits well. More baking paper goes on top and all the bubbles are squeezed out. We have another 3D printed form that goes over the joint and that helps us compress it down to squeeze out some of the epoxy. And a heavy weight goes on top of that. The next day we can take off the baking paper and remove the tube. We repeated this process another 5 times, so that also took several more days. The last bit of reinforcing that needs to happen is the other side of that pad joint. This angle is really acute, so for this we're using 3 layers of 200 GSM fiberglass. When it's all wetted out on the baking paper, we use a hacksaw blade to help force the cloth into that gap. A couple of days later, when we've done all of them, we can finally remove all the masking tape. This now left a lot of sharp edges that need to be cleaned up. Altogether, there were about 26 separate gluing events that needed at least 6 hours to cure each time. It's a little heavy, but definitely feels very solid. The bracket weighs 440 grams. So that's it for this week. Next we need to install all the electronics, the staging mechanism into the bracket, but that's for another video. In the next video, we're going to have a look at the top ring. So this is the ring at the top of the booster that holds the sustainer from falling out sideways, basically. So stay tuned for that. Thanks for watching, and we'll see you next time.